Well, good morning, everybody. First of all, what I want to do is say thank you to the organizers for letting me be here in the stage. I feel very excited here to be here because since I started working with DNA tools, I took advantage of the knowledge of you all in the community through the forums, videos. There is a massive amount of information that makes the life of a programmer easier. Okay, so I feel very excited because I feel that now I have the opportunity to give a little bit back to you, okay, of what has been given to me. So hopefully with this presentation, some of you will get some tips and will help you during the progress of your project. Okay, so that is my main objective today. So first of all, let me introduce myself. My name is Iker. I coming from Spain. Okay, so I live in Madrid, which is a bit sunnier than Scotland. So this is for the organizers. Weather in Madrid in September is awesome. So just for the next year, it's a suggestion. So I studied telecommunication engineering, and as soon as I left the university, I started working with NI. I first started working as a sales engineer, and then I moved to the technical part as an application engineer, and I did support. Normally, I didn't have any issues, saying that I was doing support, but with the last presentation that was given yesterday, was like, okay, I don't know if I must still say it. Okay, so during my experience in NI, I got my certification, CLA, CTA, whatever, and also I deliver training courses, so I'm a CPI, okay? And since 2021, I'm working as a senior software engineer in Ulma Embedded Solutions. Let me just introduce very briefly the company I work for. Ulma is a huge company. Is divided into 9 different business units, and they are very different one from the other. For example, there is a business unit dedicated to package machinery or packaging, okay, for example. Other one is in the construction area, okay. So they do very different, or they work in very different industries. I just want to highlight one thing in this slide, and is that the type of industry that Ulma is, which is cooperative. Okay, so that means that the workers are the owners of the company. So the workers take part in the decision when you need to make a decision in the company. The workers take part in this process. Okay, so it's very different of a company where it's owned by a family, one guy, or stakeholders. And Ulma Embedded Solutions is one of these 9 business units, is the one I'm working for. And it's also divided into 4 lines, okay? You can see a little bit which are the different lines. The one that I'm working on is the test automation and test benches line. Basically, everything that needs to be an automated measurement, we can deliver the whole process, okay, the whole project. So, being introduced a little bit myself, now what I want to share with you is the process that I've been gone through, okay, during the execution or the development of a project. And I want to share with you how I went through this process since the very beginning in the requirements gathering until the implementation. Okay, sometimes it's good to have just let's say the final implementation. Like, okay, I had this issue and I did that, but I feel also interesting to know which is the rationale behind. So how the programmer thought how to address this issue. Okay, so this is what I'm going to try to explain. So at the initial stage, okay, it's the requirements gathering. I think everybody has been in this situation in front of the customer, okay, and the customer is blah blah blah. The sample frequency is 1 kilohertz, and you say, okay, And then I need to get temperature from 25 temperature sensors. OK, it's fine. And then the application has more than 50 synoptics. And then you go like, what? Wait, what? Like, your mind explodes, OK? But as we are good professionals, you say, OK, I like the challenge, OK? And the next step is, OK, it's a situation that always happens. It's like, OK, after that, this is the big part, OK? But customer always has a joker, and it's like, OK. And I need to visualize them on different floating windows. So not only have the synoptics, but I want to have them in different floating windows, open them, close them when I want. OK, so it's like, OK, fair enough. Let's go. So you take the car, and you go like on the road thinking, like, OK, what I have to do is, OK, an application with 50 synoptics, all of them running at the same time. But then your implementation part, OK, of your brain starts thinking like, OK, what I want to avoid. It's 50 pieces of code, but I don't want to be copy and pasting them, OK? I don't want to repeat the code 50 times. What happens if I need to add a new feature? I don't want to add one by one this new feature, OK? And in this case, I needed to share the knowledge with the customer because they were also involved in the implementation of the project, OK? So I need, you put all this in the shaker, and then you have to come up with a solution. So on the third stage is the analytic. So I want like, OK, I have to do all this. Let me synthesize it, because otherwise I won't be able to address these requirements to a solution. So basically, the Synoptics requirements, you can synthesize it in two main ideas. Okay, so basically, a synoptic is a piece of code that it gathers data, and you have to present it, okay, on one side, and then you have to get events from the synoptic and send it to the controller. Okay, so the first point is, okay, all this I need just a piece of code that gathers data, and it's able to visualize it and generate data as well. Okay, okay, this needs to be repeated 50 times. Okay, then what is different between each synoptic basically is the picture, the pictogram. Okay, so what you are going to represent, like the picture. Okay, so at the end, what I have is a piece of code that all of the synoptics are going to do the same thing: gather data, visualize, and generate. And on the other side, what is different from one to the other is just the picture, basically. Okay. So I made these questions to myself. So, is there any way to execute multiple processes but that have the same functionality? Okay, and I put like a tip there, clones. Okay, so I started wondering, like, okay, do I know any tool capable of providing me this functionality? And rapidly, I selected the QMH clonable modules as the way to do it, to implement. Okay, so we use the QMH as the by default framework, so this was pretty straightforward. Okay, the decision. And then, is there any way to have a collection of elements that share common properties and methods, and at the same time they own? Okay, so yesterday there were some presentations talking about object-oriented programming. So I decided to implement this part object-oriented. Okay. So now I have the tools that I'm going to use to address these requirements. The next step is, okay, take paper, and a pen. I'm old school for that, so I put myself in front of a paper, and I take my pencil or pen, and I start drawing. Okay, so on one side, what I'm going to have is the DQMH clone module. At the end, it's going to have in the main front panel, in the main VI front panel, I'm going to put there a sub-panel. And then I'm going to have a Synoptics UI class, okay, which is going to run, it's going to have a run Synoptic VI, and I'm going to define subclasses where the VI that is going to be run is the one that in the front panel is going to have the synoptic. Okay, so the idea is take advantage of the object-oriented programming in order to just provide the instance of the object, insert in the sub-panel the VI that I want to visualize, okay? So at the end, I'm going to have an application that is going to start the several instances of the module, okay, of the clone module. To each one, I'm going to provide an object, okay? And this clone, what it's going to do is run the synoptic that I passed as parameter, okay, the instance of the object, and automatically insert it in the sub-panel. So by doing this, I have a unique clone, module, multiple instances of the same module, which is the synoptics, and at the same time, I'm able to insert in the sub-panel of this module whichever synoptic that I create in the class, okay, as a subclass. So this is the theoretic solution, okay? Then the implementation. So very easily, I mean, here what I'm just showing is well, how the synoptics module looks like. Okay, it's a well, for those that have used the DCOMH framework, may be familiar. So this is a module, right, a clone module. And then on the right side, you have the classes. Okay, so I have the top level class that will have the run synoptic VI method that will launch the synoptic X, okay, UI VIs. Okay, so the ones that are marked here. So hopefully the idea is clear. Okay, so I have the clone module running a VI that I take advantage of the class in order to just providing the instance have the synoptic. So which are the challenges in the implementation? The first one, the communication between the DCOMH clone and the synoptics user interface. Okay, so come on, they are VIs that are running in parallel. We cannot wire them. Okay, so this is LabVIEW 101. So I have to find a way of communicating with it. The solution, I use a user event. Okay, so basically in this run synoptic VI, I create the event. I provide the reference to the let's say to the VI that is launched. Okay, and when I want to update the data, I pass the data through a user event. Okay, to in this case to the synoptic A UI VI. Then stop. Okay, so I don't know how you do, but in my case, whenever I have to run things in parallel and I have multiple while loops, the first thing I do is find a way to stop them all properly. Okay, so before doing anything else, I try to make them all stop properly. So in this case, I try to do the same thing. Okay, so basically, the way I'm stopping this VI is okay. The clone module by itself, it's providing a broadcast event. Okay, that is module did stop event. So I'm taking advantage of this event, and I'm registering this VI to this event. Okay, so I'm taking the reference, I'm registering it, and when the clone stops, automatically this VI stops as well. Okay, so here you can see the code implementation. On the right side, you have the run synoptic VI. This is common for all of the instances. Okay, so I provide the path of the VI that I want to run. This will be gathered, but some code before. And what I do is get the module did stop reference and provide us as parameter using the run synchronously property method, okay, to the synoptic UI VI. So by doing this, I'm stopping this VI, okay, that is running in parallel. And at the same time, I'm creating the user event that I'm going to use to provide data to the synoptic, okay, and I'm registering just at the beginning. Okay, so I have addressed the communication from the clone module to the Synoptic VI. How do I do the opposite? Because I said that in the Synoptics you will have like buttons, you need to open a valve, you need to provide set point, stuff like that. Okay, so you need to provide somehow data to the module as well. Okay, in this case. So what I do is I create an event in the DQMH framework, okay, which is pretty easy. That is going to provide the data to the clone. Okay, so it's a request event, and is what I'm using to provide this data going from the Synoptic UI to the clone, and then the clone will do with it what it needs to be. Okay. So this is the implementation of this solution, of this challenge. Okay, so when you create this kind of request, you get like in a public API the request, and then you can use it outside the module wherever you want. So here I'm using it in the module that is being launched by this very same clone. Okay. Here, okay, you can see it, but the module needs an ID because I have different clones. So each clone will have an ID, and the request event is common. So I need to provide which is the clone I want to provide this event to, okay, this data to. So I need also to provide at the beginning, when I run in this VI asynchronously, I need to provide also the ID of the clone that this VI is going to send the data back. Okay. Okay, and this is the last challenge, is okay. I want to provide data to the user interface, okay, to the Synoptic user interface. And what I have to do is just address the data that is coming with the controls and indicators. Okay, so I want to make my life easy, so I can address with a string, okay, which is the channel I want to read and the indicator I want to map it to. Okay, so to make it easy, I selected the map data type, basically. So in this user event that is sending data from the clone to the Synoptic user interface, I'm providing a map. Okay, so basically, well, this is an example. Basically, after that, what I do is just map the control and the channel with the same name. Okay. Okay, so let me just show you this working. So, well, with each module that you create in the DQMH, you have a tester. So thank you. This is awesome. Okay. And if I run it, okay, I just create a couple of Synoptic. Okay. I'm going to run, in this case, Synoptic A. Okay, so I created an instance, and then Synoptic B. Okay, you can see here that each Synoptic has random channels related, okay, with by default values. So if I show the Synoptics, okay, what you are seeing here is 2 instances of the same DQMH clone, and on the sub panel, these VIs that I created inserted. Okay, so this part is done. Now, if I send messages, sorry, if I send data from the clone to the, for example, to the Synoptic, okay, you can see here, for example, I can change some values. Okay, for example, here 5, whatever. Okay, you see that here it changed. So the idea is, okay, I have this module working. Now I can get this, put it in a whole application where the data is coming back and forth from a module that is gathering this data continuously. Okay, so I know that my module is working. So if then something is not working, it's not part of my, it's not in my part. If I select the other Synoptic, okay, I come here, and I'm going to change a couple of values. I send you see here on the top left, okay, the values. So using this common, let's say, approach, I can send data to any Synoptic that is running, okay, just selecting to which Synoptic I want to send the data, okay. With this, I demonstrate you how to send the data, but I said I also need to generate. So for example, here, okay, I have some controls. For example, let me make it easy. This one, okay? And you can see that as soon as I move, I get the event, and here I represent the channel that has been changed. Okay, so in this case, it's dial from Synoptics A, okay, and the value is 2. But if it was from Synoptic to these buttons, okay, you can see at there how it changed, okay. So with this approach, I was able to work with the customer because I created the approach, let's say, or the architecture. I provided it to him, and he was building Synoptics because they didn't have them. Okay, so they went on building the Synoptics, and easily they were able to escalate, okay, to scale the number of Synoptics that they were building continuously. Okay, so it made the trick.
How long, much further do you think you have?
Yeah, it's the last. Yeah, just the last slide. Did I want to? Okay, sorry. Oh my God. I know it was going to be challenging, not that challenging. Sorry. Okay, so just to sum up, the only thing that you need to do to to make a new object, a new Synoptic, is just create the user interface and do some include some functionality in the override functions, and a couple of things. Okay, there is room for improvements for sure. So this is the approach I did, and I mean, I know that a couple of improvements can be done, but yet I haven't done them. Okay, so thank you very much.